This conference will now be recorded. This conference will now be recorded.
Okay, so in today's session, we are going to learn about the sorted internal table and hashed internal table. Okay, sorted internal table and a hashed internal table. Whatever till now we have seen, we have discussed only about the standard internal table. So we are having three types of internal table. Okay, and I will give you the idea where to use which table. Okay. So let's go to the MS Paint, and here I will just write it about the internal table. We are having the internal table, and we are having three types of internal table. Okay, one is a standard internal table, most widely used table. This is the most widely standard internal table, and it's going to be used most widely. You will be observing it's used most widely in your actual project, and everywhere, most of the places you will be able to see these particular things. That's why we have discussed in so much detail about this standard internal table. We can perform any kind of operation over here. In a standard internal table, we can perform any kind of operation. Okay, that's the beauty of a standard internal table. We can use the append statement to insert the record, to append the record at last. Okay, when we are going to talk about the sorted internal table, this is our sorted internal table. Let me write it over here. Sorted internal table. Here you cannot use the append statement to append the record. Why you will not use? I will let you know in the moment. Okay, then we are having the hashed internal table. The third internal table is the hashed internal table. What is this hashed internal table? Why it is required? So hashed internal table is basically used to access the very large amount of data set. So when I tell the data set, that means the chunk of data. That means very large amount of data. When we'll have to access over there, then we are going to use the hashed internal table. But some prerequisite is there. Okay, that we'll have to follow.
Hello.
Idea. Okay, I will just give you a brief idea like what's the pros and cons, and then we will go into the system and we will see in the practical mode what is the pros and cons. Okay, so in standard internal table, let's start with the standard internal table. So this is mostly suitable for 100 records. If you are having 100 records, in that case it's fine. If you go and check the SAP standard documentation, it tells it is suitable for 100 records. But suppose if you have why it's suitable for 100 records? Because by default it performs the sequential search, right? We know about the sequential search. By default it performs sequential search, means from one side to another side, step by step, it performs the search. So by default it performs the sequential search. Okay, now another point over here, that this is the case when you are going to use the standard internal table by default. But when we tell that it's a suitable for 100 records by default, means you can have some workaround and then you can use for more than 100 records, like 1000 records, 10,000, 1 lakh kind of record. You can use this standard internal table. So what is that workaround? So mainly we are bothering about the sequential search, right? Mainly we are bothering about the sequential search because sequential search is very costly. Costly means time taking, right? If you have some large amount of data, and if we're going to, suppose if we are having the large amount of data, then suppose we are having 1, 2, 3, 4, 5, 6, 7, like that. We are having the data, and if you have to search this particular 4, it will start looking from left side. It will check this one is 4 or not. It will start comparing. This is not 4, then it will go and check for this 2, then this will go, and then this will go like this. So one by one it will search. It will not perform the binary search. The binary search, we know, divide and conquer, right? Divide and then search. This is not that method, but we have a workaround. What is that workaround? What we can do, we can sort the internal table, and then we can use the explicit binary search on the standard internal table, right? So in that case, you can use more than 100 records also, you can use, but this workaround you will have to follow. Okay, you can use more than 100 records, but the workaround what you will have to follow, but workaround you will have to, you know, just a second. Okay, so you can use more than 100 records, but the workaround you will have to follow, like, sort the table, sort the table, and then use the band research, right? This you will have to use. So this is one point. Okay, another point here, let's come to the sorted internal table. One by one we will see the point, and then we'll try to understand what is, like, how to, which to use when. Okay, so in the sorted internal table, here you don't have to sort the data. Okay, by default the data in the internal table will be sorted. By default data in the, data in the internal table will be sorted. So if you are going to declare a sorted internal table, okay, by default data in the internal table will be sorted. But how it will be sorted? You will have to specify the key over here explicitly. Okay, you will have to specify the key over here explicitly. So this data gets sorted based on the key. This you will have to specify. And another important thing I would like to share over here. Let me open one another MS Pen. See, if we are going to talk about, the key concept, the key is nothing but, through which we are going to identify some entry. That's the general meaning of the key. That's the generic meaning of the key, through which we are going to identify the entry in the table. We are having two types of key. One key is known as the primary key, and another is known as the secondary key. Okay, so this is, I'm talking in terms of internal table. Okay, in database table we are having candidate key and all. Okay, primary key, secondary key, candidate key. This is not the case in terms of internal table. With respect to internal table, this is not the case. We are having two cases for this key. One is primary key and another is secondary key. Okay, now we will see what is primary key and what is secondary key. So it is same as, this primary key and this secondary key. This is same as the, like, for if we take any database table, we have seen that we are having the secondary index over there, right? So the secondary key is used for the internal table. Okay, the secondary key is used for the internal table to access the secondary index. Okay, so this key concept we are talking with respect to internal table. However, you know yeah, so you don't have to get confused with the database table and internal table. Internal table, it's a dynamic data object where you can keep on adding the data, and the size of the table will keep on increasing at runtime in the program session memory, right? During the program session. So that's the internal table, and we require an internal table to access the data, to manipulate the data from the DB table, right? All this fact we already know. So this is, we are having the two key, and let's now come to this point. And here this data gets sorted based on the key. This you will have to specify. So you will be having two types of key, primary key and secondary key, right? So by default data gets sorted based upon the primary key. On secondary key, it will only get sorted when that key is going to be used somewhere. Okay, when that key is going to be used somewhere. So I will show you in practical. So based on primary key, it's going to be sorted. This you will have to specify. Okay, here you cannot use append. You can't use append. Can't use append. Why you can't use append? Because the reason behind, see, when we are going to use a sorted internal table, what happens that you are having, uh, that primary key and secondary key. So in case of primary key and secondary key, if we're going to use the append at last, it will not support. So what will support over here? Here it will support insert operation only. It will support insert operation only. So here it's going to support only the insert operation. Okay. So this is very important. It's going to support only the insert operation, not the append. Okay. Now, if you are going to search anything, okay, if we are going to search anything, that means if we are going to use the read statement, then what it will do, that it will by default apply the binary search. You don't have to write explicitly the binary search as you used to do in standard internal table, right? So while searching, you don't have to tell, while searching, you don't have to tell that uh, explicitly that use binary search, right? So this is once again, yeah. So this is the point you'll have to think about. Okay, just give me a second. Okay, now it looks fine. Okay, so here I have written actually the binary search. It got overlapped, no issue. So binary search, fine. And here in the hash internal table, in the hash internal table, here you can neither use append, neither you can neither use append nor insert. Nothing will support over here. Then how to put the data, right? Then how to put the data? And here you can see that it is having the binary search. In sorted internal table, we are using the binary search, right? In the sorted internal table, we are using the binary search. But in the hashed internal table, no binary search, no sequential search. Here you will be having the key based search based upon the hash algorithm. Okay, based upon the hash algorithm. So let's understand about this hash internal table, how it behaves. Okay, so suppose if you have some table, right? So let me open one Excel and then I will show you over there. It will be easy for me to show over there. Meanwhile, let's go to this program. Let's create one program. Just a second. System looks, it got hanged. Nothing is happening. Okay, no worries. I will close it and again I will open. Okay, we got our Excel open over here, and now suppose we are having some table. So for example, suppose MATNR, material number, right? Or maybe I'm just going to take the field 1, right? Or field 2 or field 3. We are having some field like this, okay? And we have entry like this 1 2 3 4 5, right? Or maybe I'm just going to put Ram over here, Ram, Sham, okay, Sham, Shiv, okay, here is Shiv, and Vishnu, something like that I have pulled in this. So field 1 is our name, okay, and here some ID, some employee ID or something like that, I'm going to put it over here. So not in fact let it be ID. Second name I will just put last name, okay. So last name Ramdev, Dev 1, okay. Like this I'm just going to put the okay, fine. So this is something, this is something we are having the name, and here some in the field 3 we are having some occupation, right? So someone is teacher, someone is engineer, right? Teacher, engineer, something like that we are having. Let's suppose everyone is engineer. Now what I'm trying to do here, if you have to let's go step by step. First we'll start with the sorted standard internal table. First one is the standard internal table. So in a standard table you can use the append over here. If you have to append the statement, you can append over here, right? And here you can see in the standard internal table, this is the standard internal table. I'm talking about the standard internal table. A standard internal table. So you can append. It will not be by default sorted. You will have to sort it based upon the field on which you are going to perform the search, right? This we know already. Now if you are going to assign the same data in sorted internal table, so first I will tell you how you can define the sorted internal table, okay? How you can define the sorted internal table. So let's come over here. You will be having the types statement over here, right? You will first have to define, as usual, begin of ts underscore. Suppose some table is there. Let's suppose this is the table which I have defined over here, some employee table, okay, or some yeah, let's take some employee table. And here what we'll have, the component I'm just going to give over here. So the component I'm having, the first component is the first name, right? So first underscore name type I will give, and here the car10 we can give something like this, and the last name type, and we can give some car20 or car10, that's fine. And here the occupation one field we are having occupation over here, which we have defined car 20, let's suppose, and end of ts underscore emply. right? So this is the structure of my internal table, right? And now you are going to define the you are going to define the sorted table. So how to define the sorted table? We'll have to define the sorted table. I will show you just a second. Okay, so I will define something like this, it underscore name of the internal table is tab type table of uh, so you have to tell actually if you are going to give type table of, if you are going to give, let me show you. Copy this, go to the standard internal table, paste it over here. Okay, let's paste it, and here copy, and I will paste it. So here you can see that, here you can see that if we are going to use the standard internal table, we are going to declare the standard internal table. How we do? It underscore, let's name of the table it underscore table, type table of, right? Type table of ts underscore employee. This we write generally standard internal table. When we talk about the standard internal table, this is what we write. Okay, so by default, the meaning of this becomes by default, it underscore table type standard table of ts underscore employee. So if you don't give anything, you can see, if you don't give anything, then by default it is just a standard table of ts underscore employee. Okay, if you don't define any primary key over here in terms of a standard internal table, let's define the primary key and secondary key, how it behaves, right? If you don't give any primary key over here explicitly, then what will happen? The non-numeric key. So all these are the non-numeric key. All these key combination will behave like a primary key. Okay, this is also known as the standard key, right? This is also known as the standard key. This we have seen in our last class. Just I'm making revise over here so that you can relate with the sorted internal table and the hash internal table. So now come over here, and if you want to define explicitly your own primary key, what you can do? You can, so let me show you that also. Okay, so here come, and you will have to give, right? So with primary key, you have to write over here primary underscore key, and you will have to give the components. Okay, components. What is the component? The first name, last name, and occupation. It depends on you what you want to put the primary key. Okay, what you want to. So suppose if you want to put only the first name, then you can keep. Now you don't have to bother about this should be unique or not unique. Okay, you don't have to bother about this. So in a standard table, your key can be non-unique also. Means your key can have multiple record. Here you can see Ram is 2 times, Sam is 2 times. That is not a problem. This internal table will contain this data. So duplicate entry can also have in the standard internal table, right? Now, along with this, if you want to define the secondary key, okay, along with this, if you want to define the secondary key, how to do? So what you will have to do, I will show you that also. Okay, everything will be the same here at last. Here at last, what you will have to do, that you will have to write with, again you will have to write with, and suppose the secondary key is sorted type or hash type, so you can give like this: sorted, sorted sorted unique key or non-unique key, unique key, and then you can give the name of the name, you can give the secondary key name. So by default, by default, first will be the primary key. First you will have to give the primary key, and then after you can start giving the secondary key, as many as possible. You can give some certain number of secondary key. I don't remember the exact count, but you can give, I think, around somewhere around 20, 30, like that you can give. So many you can give with sorted unique key, and the name you can give for the sorted unique key. For the secondary key, you can give something like ASO underscore test maybe, and here also you can give the components. So like that you can give. So here you can see, and in the component you can again give the field name. Suppose here you want to use two key, name and last name, so you can use the name and last name. Okay, so this is how you can define in the standard internal table the primary key and secondary key, right? The primary key and secondary key. Let's come to the sorted internal table. Sorted internal table, and here
Sir,
uh,
sir, sorry for the interrupting. Someone has
yeah,
opened the camera, sir.
okay, okay,
See,
yeah, yeah, yes, yes, in just a second. Yeah, now it is still there. Yeah,
yes, sir. Still camera is on, sir. Shiva Reddy
yeah,
something.
yeah. Shiva Reddy. Shiva,
Yeah.
Your camera is on. Shiva, hello, hello, Shiva, are you there? Hello,
Yes, yes.
Camera, your
Hello.
camera is on.
Oh, yes.
your camera is on. Okay, now it's fine, right? Okay, fine. Okay, let's go ahead. Okay, let's go ahead, and now we will see that how we can define it over here, right? So how we can define it over here. So instead of defining it over here, let's go to the system and we will define over there. It will make more sense, and then we will copy the code and we will paste into the we can paste it over here for our difference. So let me go to the system, and here just give me a second, it's trying to, okay. Okay, so let's write a program over here, and this program will be ZMB28, and let's give me Z over here. Okay, and now this is the last program. We are going to give the 17th program. Click on this create button, and we will give the sorted internal table, and then we will see the hash internal table. Sorted internal table, and then we will go to the hash internal table. Okay, so what I was talking about actually in this Excel sheet, why I have opened, in case of sorted internal table, when you are going to put this data into the sorted internal table, what will happen? Automatically it will be sorted. It will be sorted based upon the key. Suppose if you have defined this first two key field, then what it will do, in Excel, how we on the two fields we sort. So generally we go into the sort over here, right? And here we can give the column A value A to Z, and we can add another column and column B, like that. So name and last name, right? So column A and column B, two data I'm just going to sort, name and last name. If I'm going to define this first name and last name as my key column, it will sort based upon this. Click on this, okay, and you can see it got sorted. So like this, you'll know, like this it will get sorted. I will show you in practical how it's going to be happen. Paste it over here, and this is my original data. Okay, here I'm already having the original data, so I don't have to bother. Fine, I will just remove it, control Z, and now here this is there in the sorted mode, right? Yeah, this is in sorted way. This is the sorted data. So internal table, our data is going to be sorted in this way only. When you are having the hash table, data is not going to be sort automatically or something like that. It will be there as it is, you are going to put. So all this data, it is going to be there as it is. But in the hash internal table, what you will have to do here, you have to define the unique key. Why? Because the hash algorithm works on the unique key concept. Hash algorithm works on the unique key concept. Okay, hash algorithm works on the which concept? Hash algorithm works on the hash algorithm works on the unique key concept. Unique key concept. So you must have to look, you must have to find out which is going to make your unique key. Then only you will be able to access, otherwise you will not be able to use the hash table. Hash table is very beneficial when you will have to access large amount of data. That means when you will have to search something in large amount of data set, because the search is not going to be sequential or binary. It is going to be based on key. Okay, it is going to be based on key. So how it actually going to work? What happens when your table is a hash table, then you know that in how your memory address is going to be organized. Let us suppose this is your 1000 address, then this is your 1001 address, then 1002 address, something like that. You are having this address, right? So you can see that this is the memory address you are having. Okay, so on this memory address, okay, the first address, on this first address, the key field. So here you can see, here you will have to decide what is the key field. So while declaring the hash table, you will have to define the key field, which should be able to identify the record uniquely. This is important thing over here. Okay, this is very important thing over here. In a standard table, you don't have to bother about the unique or non-unique. In sorted internal table, this can be unique or non-unique. In sorted internal table, you can have unique key as well as non-unique key also. Unique key as well as non-unique key also. Okay, non-unique key also. In a standard internal table, you will be always having the non-unique key. Okay, non-unique key. This means you can always have the duplicate data. There is no problem in a standard internal table. That's why it is most frequently used, right? And the sorted internal table, both option is there. If you are going to specify the unique key, you must have to put the data in that way. If you are going to specify the non-unique key, your data will behave like a standard internal table. Okay, come into the hash table, and here we will see. So suppose here you can see the Ramdev1, Shamdev2. So this name, first name, right, and this first name and the last name is going to identify your record uniquely. Okay, this first name and last name is going to identify your record uniquely. You can see all the record is unique over here. This is unique over here. It's going to define uniquely. So similarly, all of the records also we are having, right, the unique. Okay, so all these are the unique record. So based upon the Ram and Dev, the hash algorithm will be defined by the system itself, and with Ram and Dev. So using this Ram and Dev, it's going to make some key. It's going to define some key. So corresponding to Ram plus Dev, system is going to make some key. Let us suppose some key is X. Okay, so for this particular, for this Ram and Dev, it's going to have the X key over here. And now once the key is generated, this X will be mapped with this Ram and Dev. Okay, so this X will be mapped with Ram plus Dev. Okay, now for this Ram plus Dev 1, for this Ram plus dev1, what it is going to happen that another key will be generated. ram plus dev1, another key will be generated. So let's suppose this another key by the system is going to be generated like something like y. Okay, similarly Syam plus dev, this Syam plus dev will be having some another key. Okay, Syam this is going to have, let's suppose, some another key. Maybe I will just write it over here, Syam plus dev. This is going to make something like z. Okay, so now now similarly every record Syam dev 2, it's going to create a unique record. Okay, it's going to create a unique record, and here also you can see that we are having the shoe plus dev, using the shoe plus dev, whatever the key field you will define, based upon that it's going to be create a unique key field. So Syam plus dev 2, let's suppose this is a, it will create some a field, or this will create some b value. And unique hash key, this key will be known as the hash key. Okay, this so hash key will be generated based upon this hash key is going to be generated based upon the unique key. Once your hash key is going to be generated, then when you are going to search your table, okay, suppose now you will have to search your table. So what you will pass next time you will have to pass the key, because you cannot pass the index like 1 2 3 or something like that, as we used to do in standard table. Same index can be used in sorted table as well, but in hash table you cannot use the index. Okay, in hash table you cannot use the index, right? Because you don't know on which index which one is going to be stored, right? On which memory address what is going to be stored, you don't know. It is going to be defined by the key, right? So you have to supply the key in order to search the table. So once you are going to supply, suppose Syam and dev 2, then again it will form the key what corresponding to Syam and dev. As per the hash algorithm, it will form this z, and it will start searching in this it will start searching into this hash key. Okay, it will start searching into the hash key. And the mechanism of searching the hash key, it is in such a way that it is independent of number of records. It is independent of number of records. Like, it is not going to be sequential search like where is z, where is y, where is a, or something like that. It is not will be the sequential search. This z, system knows on which particular place this z is stored, on which particular memory location this z is stored. System knows. In system, the program has been done in for the hash table already in such a way that it does not have to go and search sequentially. Once it identifies that this is the z, it will soon start pointing with the help of program this z memory location. And we know that this hash key is mapped with the Syam plus dev, and Syam plus dev will start pointing this particular record, and all the record you can access in this way. That's why the hash key, that's why the hash algorithm or hash table is independent of number of records, because it's going to search based upon the hash algorithm, based upon the hash key. It is not going to search one by one from left to right, or it is not going to search based upon the binary search. It is just going to determine the key based upon the key. It is finding the hash key. Based upon this key, it is finding the hash key, and system knows where is my hash key is already stored. It will start directly pointing to that particular place, and once it will start pointing to that particular place, it will soon start pointing this particular record, and you can access. So it happens in all the cases. That's why if you have large amount of data, you don't have to bother about the performance if you are having the hash table. So it's a but the problem is there, you cannot use the insert over here, you cannot use the append over here. Data data manipulation is difficult over here. but data accessing, if you want to access the data, if you want to read the data, that's going to be very fast. That's why though it is so powerful, but is not useful in a common scenario. Okay, in common scenario it is not useful. It is mainly used in BI/BW project, BI/BW project, where we are having the large amount of data, right? Business intelligence, and in business warehouse we are having, large amount of data. The data need to be read in such a way that it will be useful for the business. So there we will be having the like 10 years ago data, 20 years ago data, large amount of data we'll have. And when we'll have to read that data, generally we go for that hash algorithm. And if it is really very critical in our scenario also, means in common scenario also, we go for the hash table. Okay, we can go, but another limitation is also like, the administration cost increases. So when we tell that administration cost, what's the meaning of administration cost? Administration cost means when you are going to use the hash table, it has to use the hash algorithm, right? It has to use the hash algorithm. It has to use the memory. Extra memory will be required, right? Extra resources will be required, right? So this will come under the administration cost. This will be known as the administration. So when you are going to use the hash internal table, your in administration cost is going to be increased. That's why if you have less amount of data like 100, 500 or 1000 like that, you are not supposed to use this hash algorithm, because it's a very costly in cost of in terms of administration cost. Okay, similarly the case is for the sorted table. Here also you have the administration cost, because it is the sorted internal table, administration cost. So if you are going to put the data, there will be some mechanism, right, which is going to automatically sort over here, right? So when you are going to make your internal table, and when you are going to put the data into this, automatically it is going to be sorted. So there certainly some administration cost will be there, like some memory consumption, some resource consumption, like that it will be there. That's why the sorted internal table is also not recommended if you have some less than 100 records or something like that. Means in terms of if you have less amount of records and performance is good, then go for a standard internal table, right? And in a standard internal table also you can use the bandy search, right? You can use the bandy search by sorting the table. So why not to use a standard internal table? So that's why standard internal table is so much popular. But in some real scenario where really it requires, some scenario, maybe I will tell you here. So come to the system now and we will see. Okay, the system is not supporting me. Let me connect with another system. Okay, so this is about the theoretical concept. We'll see in the practical mode. You might be getting bored now, so let's come and go to the program. We'll create one program, ZMB28, and program number 17, right? Click on this create button. Sorted internal table, sorted internal table demo. Okay, executable program, local object, like this. Come this, I will directly copy this one, so I will not have to write once again over there. And let's define this. This is my structure, right? And here, once again I will just make you revise. Declare one types. For a standard internal table, what you will have to do, right? For a standard internal table, it's easy. TT underscore EMP type. So table type I'm just declaring. Type table of TS underscore EMPLYEE. So when I'm giving type table of, so that's meaning means type a standard table of. By default, it's a type a standard table of, right? And by default its primary key is going to be it's a standard key. So here all is the character data type, you can see. So all is going to become your primary key. If you want to explicitly give your primary key, so you can give like this, with key, name of the primary key, and name you can specify some primary key name you can specify. So let's give some name, something like pk primary key 1. Okay. Sorry, this is already primary key. This is the name of the primary key, primary key itself. You will have to now mention the components. What is the component here? First name and last name. I'm just making it a primary key. So, or let it be like one only, first name. I'm just making the first name as a primary key. Now, if you want to use the secondary key, just you can use with. So for secondary key, you know, what you can do with sorted table, actually this syntax is something like with sorted key, and the name of the key you will have to give over here. So name of the key, maybe you can give let me check its syntax. It looks some problem over here. So okay, that we will check. But here something like that, you know, with sorted key ABC, something like that, and then again you can use the components for this. So now it will become your secondary key, ABC components. And here suppose if you want to give first name and then a last name, we can use like this. Okay, so click on this pretty printer. Some problem is there in syntax. Okay, but that's how with sorted key ABC like that you will have to write it. I will check and I will confirm in this session itself. Let's go for the sorted internal table. So this is how we are going to define the standard internal table, but generally we don't have to go like this much, all these things. Let's go for the sorted internal table. So this is how we are going to define the standard internal table, but generally we don't have to go like this much, all these things, right? Most of the time we have been using till now up to here, and this is sufficient. No, you know, not required to write all these things. Just for knowledge purpose, you know, I'm just telling that this is how, if you want to explicitly define the primary key, you know, you can define like this, but not required, because by default the standard key will be primary key, right? So not required. So this much is only going to be frequently used. Now for the sorted internal table, if you want to define the sorted internal table, so generally table type we define like this, tt underscore emp. Now I'm going to define the sorted internal table. So tt underscore sort internal table, it, I'm just giving type sorted table of, you'll have to write sorted table of ts underscore employee. Okay, so now what will happen that, you know, the data, this table type is now going to become your sorted internal table type. Okay, and here you can define the primary key. So here with unique key, so with unique key, maybe the first name and last name you can give, because this is the unique key, and the data I'm just considering this data only. Okay, so if you see here the data, first name and last name combination is the unique over here, right? So that's why I'm giving the first name and last name as a unique key, first name and last name. Okay, so this is your primary key. If you want to, you know, if you the another way of defining the same thing is like this also, with unique key, and here you can give the primary key and the name of key, something like let's suppose test. I'm just giving the test, and then you will have to give the components. Okay, so with unique key, primary key, sorry, test is not required because primary key itself is a name. Okay, primary key is itself a name. Okay, so this thing, this declaration and this declaration both is same. Okay, so in sorted internal table you must have to declare either like this is most frequently used, the first one, when you are going to use in practical way, Okay, and this also if you want you can do. Okay, so both is fine, both is fine. Second one I'm just going to comment it and I will write it over here that second, this is the first way of declaring, first way of declaring, and this is the second way of declaring, second way of declaring. Both is same, both meaning is same. Okay, first and second both is same. So just to make sure that both is same, here I'm just writing that or. Okay, that means this and this both is same. Now come over here and we are going to define one internal table. So st means let me write like this, sort tab, something like this, type, and directly I can use this types statement over here. Okay, directly I can use this types statement. So this table will now become the sorted internal table. Okay, so directly you can use this type table type. So it will be having two unique key, or another way what you can directly use, let me show you that. Here you can, let me suppose I'm keeping the name different, item underscore sort underscore tab one, type sorted table of. Okay, and the name of the structure will have to give, the name of the structure is ts underscore employee, just give this name of the structure, and other syntax will be same with unique key, just put it over here. So it will be also having the same impact. So directly if you either you give the reference of this the table type, or directly you can declare the data object by telling, by giving the reference of this structure, telling that this is my sorted internal table and it is having the two key field. Okay, so it's easy, like as we have seen for the standard table, we can declare with the help of table type also, or directly with the help of a structure also we can declare. So it is in that way. Okay, now let's prepare some data. I'm going to copy the data from there and I will directly put it over here, so it will be easy for me. Paste it. Okay, and let's prepare some data. So first I will declare one work area. All right, so let's declare the work area for this, and this is my standard table, right? So now one important thing is that suppose because sorted table you cannot use the insert statement, you cannot use the append statement, you have to use the insert statement. One point, right? But using the insert statement, first you will have to identify the index, first you will have to identify the position. So that the challenge comes into the picture. Okay, so the easy way, what we are having the easy way, first let us prepare the standard internal table. Okay, so I'm just going to first prepare the standard internal table. I'm defining one work area, data wa underscore emp, type ts underscore employee. Okay, and this is my and let's define one standard internal table. So it underscore st, standard table, s for standard, t for table, I'm just giving the naming convention like this, type table of ts underscore employee. Okay, so directly I can give this reference, or if I'm going to use this table type, directly I can use this table type, then type table of will not be required. You know already this concept in detail, right? So pretty printer, so this is my internal table, this is my work area. Now I'm going to prepare the data. So let me prepare the data, wa underscore emp hyphen the first name equals it's Mahesh. So a standard internal table will prepare, right? This is my standard internal table. Let me copy this data. I copied from sorted internal table actually, and then once I will assign into the sorted internal table, then you will see how the data is automatically sorted. So first record is Ram, full stop, and what we are having, wa underscore emp hyphen the last name, last underscore name equals, we are having the div, right? Div we are having, and then wa underscore emp hyphen, and what is that occupation, right? So occupation, copy this, paste it over here, control V, or if you don't want to copy and paste, control space, it will give you the option, shift enter equals, and then what you can do, you can write this teacher. So first record, first work area I have prepared, this work area I will append, right? So we can append into the standard internal table, there is no problem, right? In a standard internal table, append w underscore emp to it underscore emp, right? So, sorry, this is it underscore st, actually this is it underscore st, and emp I can give something like this, little meaningful, it standard table, employee standard table. Okay, so the first record I have prepared. Similarly, I'm going to prepare the second record quickly. Okay, so the second record is Ram Dev 1. Okay, and it's the engineer, right? It's the engineer, so I'll paste it over here. The third record we will create now, control V. So the third record will be Shyam. So I'm just copying this Shyam from here and I'll paste it, and Dev, okay, and then engineer, right? Again the fourth record, let's prepare the fourth record, control V, and in the fourth record we are having the Dev 2, right? Everything is same. And now prepare the fifth record. In the fifth record, what we are having, we are having Shiv, right? So use the Shiv over here, Shiv, and then we are having the Dev, right? And again paste it, and then this is the sixth record, Shiv Dev 3, put here the Shiv Dev 3, Shiv, write the Shiv over here, and this is also engineer, and the Vishnu and Mahesh, right? Copy this one, again paste it, and we are having Vishnu over here. We will give the Vishnu, and all the employee in our company who is God is now ready. Now so Dev, and we are having the engineer. Now copy and paste it over here, and here you can see that Mahesh, and then we are having the Dev 4, and then the engineer. Now let's okay, so now our now our company employee is ready. Check the syntax, some problem is there. It is telling with unique key, last name is not there. Let us see what is this. Oh, you can see here NAEM is there. Okay, that's the problem. Put the correct name, NAME. Check the syntax now, and you can see there is no problem. So you can see that a standard table is ready now. it underscore st underscore emp is my standard table. Now if you want to prepare the data into the sorted table, just you can use the copy command, or you can you can use the move command, or you can use the equal sign to put the data from right to left. So what is the name of the sorted table? This is the name of the sorted table. You can use this or this, both is same, right? Both is same, the way of declaration is different. Okay, so copy and paste it over here, and it underscore st underscore emp, and then control D, another table, both is same. Just I will show you, in both the table data will come, same data will come, because the both table is same. I'm copying the same data. Okay, now my sorted table is, my sorted table is ready, and you will see that it will be automatically, data will be sorted based upon the key. What key we have defined over here? First name and last name. So if first name and last name is going to be our key field, then the final result will come like this. So we will compare this result over there. So I will copy this, and we will see this is going to be the this is going to be my result or not. Control V, okay, and comment this one. Okay, now I will put the breakpoint, full stop, activate it, and now I'm going to, put the here also breakpoint and press F8. Okay, now this standard table is having 8 records, right? You can see the Ram, Syam, Siu, Vishnu, Mahesh, like this, what we have in this Excel, right? In the standard table, the same record now I populated with the append statement, right? Now you can see that in this standard table, that's fine, we are having the record. I'm just putting that record into the sorted table. As soon as I have put into the sorted table, now let's go and observe, okay, the sorted table record. Double click over here, and now you can see the Mahesh has come over here, Ram has come over here. It has sorted already, first name and last name, and you can also observe that first name and last name is in bluish color. Why? Because this is the key field. Okay, so debugger is also identifying that what is the key field and what is the non-key field. That's why it is coming into the blue. Okay, because this is a key field, and here the occupation, it is coming based upon this key field arrangement, right? So automatically it got sorted. You don't have to perform the sorting manually, right? So this is sorted table is read optimized. What is the meaning of read optimized? Okay, I will tell you that point. Here you come, it underscore sort underscore tab 1, and here you just observe both table is same. The way of declaration was a different, right? Here also you will see the same data, right? Only the way of the declaration was different. Here attributes, you can see this is a sorted internal table, and it is having the unique key defined. That's what it is telling the system, unique key defined. Okay, if the unique key is defined, and if you want to put the duplicate value in that, it will give you the dump. Okay, I will show you the same. I'm just going to use the same record 2 times in a standard table. In a standard table, it will not create any problem, but as soon as you will copy the data into the sorted table, the system will give you the dump. It will throw you the dump. It will tell you the sorted table is with unique key. Why you want to put the data, duplicate data? So you can see till here it's fine, right? You can see that this Vishnu and this Vishnu, here the same record I have just prepared. Now as soon as I will press F6, you will see the magic will happen. It is telling that a row already exists with this key. That means it will not accept it will not accept the the duplicate, because you are telling to the system that you know it's a unique key. Okay, if you want to make them accept, you must have to define non-unique key. If you want to use the non-unique key, then it's fine, it will not give you any problem. So with unique key and non-unique key, both is possible in the sorted table. Okay, so press effect, and here now this will not give you any error. Okay, it has not given any error, though it is having the duplicate, because I have told to the system non-unique key, right? Now suppose, and here why it has given the dump. It has given the dump because the second table is still the unique key field I have written over there, right? The second here, this table still the with unique key I have written. That's why it has given the dump. So this concept you understood. So just I'm commenting this one, and this statement also I'm commenting, right? Now I will tell you how the bandit search will perform over here. So suppose if you are going to read some data, read table it underscore sort underscore tab into into some work area, right? So let's define some work area. So I will use the inline declaration to define the work area over here. So read table it underscore sort underscore tab into work area. In this work area, the data what will be read, it will put into this. Okay, with key, what key? First name is the key, right? First underscore name is the key. Suppose I want to read the God Vishnu. Okay, I want to read this record, and the last underscore name I want to read maybe I want to read this Dev. Okay, Vishnu Dev I want to read this particular employee, okay, Vishnu and Dev. Now if Sai Savarsi is there, Sai Savarsi means if that record is found, Sai Savarsi equals to 0, then what will happen? That I'm going to, write this WA hyphen first underscore name and then WA hyphen last underscore name. Full stop, pretty printer, check the syntax, it is fine, activate it. So here I'm not giving any binary search, okay, here I'm not giving any binary search option as we used to give for the standard table, right? So this is the sorted table. In case of sorted table, automatically binary search will take place, okay, so automatically binary search will take place if it is a sorted table, and automatically binary search will take place, if it's sorted table. And this this read, this search will be the optimized search. Why we are telling the optimized search? Because this table is already sorted internal table and system already knows that this is a sorted internal table, and based upon that administration has been done that for this particular table in such a way that your searching is going to be very fast, okay, your searching is going to be very fast because this table is your internal sorted table, and because this is a sorted table, the memory management, the administration, the resource management, everything, the program, everything has been done in such a way that it is optimized, because already system knows that this is a sorted table, so already he is prepared, system is already prepared, and that's why it is known as, it is read optimized, it is the read optimized. The same thing, if you want to, if you are going to write the same thing, if you are going to write the same thing on what, on the standard internal table, if we're going to write the same thing on the standard internal table, this is my standard internal table, ITST underscore EMP, okay. So if we're going to use the same thing over here, it will use the sequential search, it will use the sequential search, okay. but you have a workaround over here. If you want to use the bandy search over here, first you will sort the data it underscore st underscore emp by, and first name and last name, right? First name and last name, last underscore name, and I'm just going to paste it over here, Control Z, copy this one, paste it over here, and here now you can, at last you can add the bandy search, that's it. So if we're going to do these two things, it will behave like a sorted internal table, but this is not read optimized, so little bit performance like you will find, okay. If we're first going to use the sort and then you are going to use the read, it will use the bandy search, but it is not optimized, because at runtime just you are doing all these things, right? You are making this table, you are making this standard internal table into the sorted internal table, and in the runtime you are deciding that this you will have to perform the bandy search, but still you will get a lot of performance gain if you are going to use the bandy search in the large amount of data, okay. So generally SAP tells that more than 100 records is there, you must have to use the bandy search. Less than 100 record, not required using this bandy search, not required, okay. So whenever you are going to use the sort and use a bandy search, or whenever you are going to use the sorted internal table, you will having some little administrative cost over there, you will be having some extra administration over there, Okay, so this here, if you would like to me that which one will be faster over here, so obviously this sorted internal table search is going to be faster. But suppose if you have already declared some internal table which is a standard internal table and you want to use those internal table for the bandy search, you can use like this way. This is also fine. Okay, this is also fine. There is very less difference if you try to compare. Okay, if you try to compare the performance, I have shown you how to compare the performance, right? You can prepare some 1,000 lines of data or some 1 lakhs data, or you can try searching, okay, some 1,000 records between out of 1 lakh records, and put the counter before and after. Here also put the counter before and after into the loop. Try searching in a loop, and after that you can realize that there is a less difference, which can be ignored. Okay, which can be ignored. Fine, so this we have seen some error is there. Let's see what is the error. WA was already declared. Okay, already declared, so WA1 I will put here. Also I will use the WA1 everywhere, it's because already declared, so maybe we can remove it. This data we can remove because already this WA is declared. So data is basically to define this work area, right? This work area is type compatible with this internal table. Check the syntax now. This is fine. Activate this. So this is your sorted internal table. Hope the concept is clear now. And now with the sorted internal table also you can use the secondary key. Okay, so how to use the secondary key I will quickly show you, and we will wrap up the session. Okay, and then tomorrow we will see some more stuff this in sorted internal table, and then we will go to the next topic. Okay, sorted internal table and hash internal table. Still I have not given any example for the hash. I will give the hash. Let me show you quickly over here. If I can show you here, you can see the secondary index. If you want to define, you can define again with something like this, with non-unique key, first name, last name. This is fine. This is the types. That's fine. Now with unique or non-unique, non-unique sorted key. Okay, the name you will have to give. So let me give some ABC something name and the components, and here you can give first name, last name, or something like that. Here you can see the first name, last name I have given as a as a non-unique key, right? I have given as a non-unique key. Now I want to give as a non-unique key, or let's suppose the unique key, the combination of first name, last name, and occupation. I want to make a secondary key, and I want to give that a unique key. Okay, so I will just copy it and I will paste it over here, and one more key is there. Copy this, paste it. So now this will become this ABC. This key will become your the secondary key. This is the primary key. Okay, so primary key, and this is the secondary key. Secondary key. Okay, so by default, if we're going to search on the sorted internal table, right, by default the primary key will take place. Primary key will take place. But if you want to search based upon the secondary index, what you will do, that with key, first name, here you will have to give the using. Actually, let me see the syntax. Using key, there is a syntax called using key. Using key, I don't know, I'm not able to recognize the, but what you can do, generally we don't use frequently such kind of the secondary index and all. Okay, but if you want to use the secondary index, you can specify the secondary index over here, where here this is the sort table, right? Here based upon the primary key it is automatically taking, and if you want to tell that start searching the data based upon the secondary key, because when you have given the secondary key over there, your read will be faster if we are going to use the if we're going to search based upon the first name, last name, and occupation, right? We are having the occupation equal to teacher. So this three field if we're going to give, because this three field is not part of your primary key, so it will not hold good the primary key search. It will hold good for the secondary key because you are having the secondary key over here, right? But you will have to specify the name of the secondary key. Okay, let me check the syntax. What is this syntax? Okay, so I will check the syntax. Press F1 over here and we will see read table, and let us see, click on this quick reference, read table, and reference into assign all field, binary search using key. You can see this, we are having the using key. This particular syntax I will have to use. Copy this one. Okay, actually this is the syntax. Okay, this is the syntax. Let me copy both. I don't know which is going to be supported, so I will copy both and we'll check over there. Come over here and I will paste it. First I will try with this with key. So with key and key name. So the key name you can give over here. What is the key name for the secondary key? It is ABC, right? ABC. So I will give the ABC and components. So this is the supporting. So I not required another one. So here I'm telling to the system, please use this particular key because I'm passing this 3 key, and for this 3 key I have already defined the secondary key, this ABC. So now my search will be faster on this. Okay, now my search will be the faster. Okay, so there are actually so much a lot of advantages in the real time. You know, if you are able to define the secondary key for one table, there are a lot many advantages, because the same table you can use multiple times with a different key access, right? With a different key combination you can use the same table. Earlier what we used to do, you know, earlier this concept come NetWeaver 7.0 service pack 2, this multiple secondary key. Before 7.0 we used to copy the data into another temporary table and then we used to sort or do something like that, because the same table was not possible to sort and to use sort with a different key. Here you can see the first, I'm sorting based upon the first name and last name, the same table, and same table I'm preparing over here for this, right? You can see the same table I'm using, right? So with the reference of same table, you know, this table you can see TT sort underscore IT, this is my actual internal table, actual data object. With reference to this I'm preparing, so this table will be having both the key, right? This key and this key also. So that's the beauty. But the problem is here, if you are going to create more secondary key, what will happen? The extra administration cost will increase, right? That's the problem. Okay, because it has to maintain the index. Whenever you are going to create any key, the internal index will be created, and for those index, the cost will be it will be costly. So if it is not required, it is not supposed to use. Okay, so that's what I wanted to tell you. So, you know, similarly in loop also you can specify the secondary index to improve the performance. So suppose if we're going to use the loop something like, you know, suppose if you are going to use the loop at IT underscore sort underscore tab loop at into, let's work area like this. Okay, and in where condition, right, in where condition you are having this first name and last name. So if you are having the first name and last name and this is the sorted internal table, by default the first index will take place, right? By default the first index, the primary key index will take place, right? So the performance will fast. But suppose you have to give the occupation also, right? This is something like this your requirement. Then in this case, you know, for the this also you have smartly created one more secondary index. So what you can do, that here you can give that using key, okay, and you can tell please use this key ABC. That means please use the secondary index, because 3 where condition is here, occupation is also over here, and for this for 3 combination we have created this particular key. And whatever you want to do, you can do over here, because this loop is nothing but a kind of read statement only, right? Wherever it will find this particular where condition, it will be true and it will go inside, right? So it will become, you know, a very good from performance point of view, right? Now one thing, you know, you have created a secondary index over here, right? You have created one secondary index over here, but the data based upon the secondary index, so what system actually will do, it will create a temporary table, and for that temporary table, based upon this you know, based upon this key field, the data will be sorted in that temporary table, okay? But when this particular things will take place, when these particular things will take place, as soon as my question is, as soon as when you are going to create this internal table, at that time itself? No, at that time itself this secondary key based sorted internal table does not take place. At that time itself secondary key based, you know, index, you know, the secondary key index does not take place. That sorting and all does not happen at that time itself. Only this primary based, you know, the primary key based sorting and everything is going to happen when you are going to create this data object, and when you are going to prepare this, you know, when you are going to prepare this data, here I have prepared this data, right? So I will show you in debugging. Once again, activate, some problem is there, let me check. Before end of the program, the structure loop, okay, so I have started the loop but I have not written the end loop. Activate this one, activate, and now come over here, just come over here, put the breakpoint, okay, press F8, and here you can see that some problem is there. It's already telling a row already exists with this key, okay? I think I have written the, you know, the unique key, right? /n sc38, come over here, change, and here you can see that, you know, with unique sorted key I have written, right? That's the problem. So come over here, and secondary key is the unique key, so it has to take care of unique key, secondary unique key also, right? That's why it is giving you the error. So I will adjust the data accordingly. So Vishnu Dev 1, I will just put it over here, and now it will be fine. Activate it, press F6, and you can see that item score sort type. So what I'm trying to tell, the sorting will be take place only the first name and last name. The second index which I have defined for ABC, first name, last name, and occupation, this will not take place at this point of time, okay, this sorting. So it will create a temporary internal table, okay, and there, you know, when the very first time you are going to, you know, this is the standard internal table, you can see the STM written over here. So here this is fine, this will take the sequential search, here it will take the binary search, but here you can see the primary, based upon the primary, you know, primary key item underscore sort tab, the primary key index, based upon the primary key index, the binary search will take place over here for this statement, okay? And here for this, the second statement, based upon, you know, the binary search, it will take place at this point of time. The data in this internal table will be sorted at this point of time, okay? Internally, you might not be able to see this one, but internally at this point of time the data will be sorted based upon first name, last name, and occupation, okay? Based upon the first name, last name, and occupation, when I'm going to access this read table at this point of time, it will be sorted, not at this point of time or before this. When the first time it is going to access with this key, then only it will get sorted based upon the secondary key, okay? So this is also known as the lazy update. Why lazy update? Because whenever it is required, then only it is going to be, it's lazy to update. Whenever it is required, then it is going to update the data based upon the secondary index. That's why it is known as the lazy update. Okay, so you can see, you might not be able to see the reflection over here. You can see that it is only showing the first name and last name, but now update has been there internally. This has been done by internal administration. Okay, internal administration, and the data based upon this, key, based upon this key, the bandit search has been followed over here. So that's the concept about the sorted sorted internal table. And here, because already it has been sorted, so here now the lazy update will not take place. Lazy update already had been over here. If this statement will not be there, this read statement, then the lazy update will take place over here. The first time it will be accessing the data based upon this key field, and then at this point of time it will be going to take place the lazy update. Fine. So this is how, and quickly I will show you, just give me 2 minutes with a short just a glimpse of the hash internal table. Okay, so for hash internal table you will have to declare one, types, and tt underscore hash, or directly you can define the hash internal table. Okay, not required to declare the types, but you can do data directly, you can do, and it underscore hash table hash tab type hash table of, you'll have to write hash table of what, ts underscore employee. So you can see I'm using the same structure again and again, but the way of declaration is going to be different, and the same structure is going to behave differently for the table, for the different table, right? Can be used in a different way, can be used, same structure can be used in a different way to declare the different internal table. Okay, so it underscore hash underscore tab type hash table of this, and here you must have to define the unique key. Here non-unique key is not supported. You can see in sorted table the non-unique key is supported, right? In sorted table non-unique key is supported. In a standard table, here you cannot give the unique key. Okay, if you see here, unique key is fine. Here you will be able to give the with unique with unique key, and you can give the first name, last name, or like that. But sorry, you can see here unique key is not possible in a standard table. Non-unique is possible. Non-unique, non-unique, remove this non-unique key, and first name, last name. So here this is the primary key. Okay, so unique key will not support in the standard table. You can see it is giving the error, right? But when you are using this, non-unique key, it is fine. So non-unique key, only non-unique key is supported for the standard table. Okay, just remember, unique key and non-unique key, and unique key both is supported in the sorted table. Okay, important difference I'm telling you. Okay, and the hash table you must have to define only the unique key. So in a standard table only non-unique key, and in the hash table only the unique key will be there. Okay, so type hash table of ts underscore employee with unique key, and you can give the first underscore name and last underscore name. And here the benefit what you will be having, the search, you are going to use the search. So if you have to search the data, right, so read table it underscore hash underscore tab with key, let's suppose the first name over here, first underscore name equals to something, any name, Mahesh, Ganesh, whatever. Okay, and then the last underscore name equals to Dev. Okay, so if we're going to use over here for the hash table, based upon the key only we'll have to search. You cannot give like this. Okay, you cannot give like this. Index to something like that, you cannot give. Index does not support for the hash table. Okay, index does not support for the right? So I will give some work area with the help of data. Let me give the test over here, and here also I will keep this into test. Already tests is declared, so not required. And if you see here, here for this particular things it will not give you error, but for this it will take index based search is not allowed. You can see the explicit or implicit operation cannot be used on tables type hash table or any table or hash tables. Okay, so here you can see hash table cannot be accessed and the pointer is here, right? Means it is pointing to this particular place. Here you cannot use this index. Just comment it, and here you can see that now there is no problem, right? Some warning is there. You can just ignore this warning, but there is no error, right? So this is how hash table. So hash table, suppose if you have lakhs record over there, it is going to take the same time. If it is having the 10 records, or if it is having the 1 crore record, it is going to take the same amount of time, okay, for to find the any record, if the record is in beginning or in between or it at last, in sequential search, if that record is there in the beginning, it will quickly get it and give you, right? It will quickly get and give you. But here in the hash table, it does not matter where a record is there, it will quickly find it out and it will give to you. Only the problem is the administrative cost, that the management cost, the memory management, resource management, this will be higher. For one record it has to it has to use somewhere around 16 bytes to 32 bytes. Okay, 16 bytes to 32 bytes, which is a large amount, all right? Okay, so in the sorted table it will take something around 8 bytes to 16 bytes, and in the standard internal table there is no administrative cost. It's very easy. That's why a standard internal table is a standard, Fine. Then with this concept, after understanding all this concept, we came to know that still whatever we have learned, most of means after learning all these things, a standard internal table is only going to be more important. After that, if you want to use this sorted internal table, you can use this one, but hash is not required. In our case, it is very rarely used. Okay, if you want, you can use, there is no problem. Okay, but you cannot do the insert operation, you cannot modify the data. Okay, you cannot modify the data into the internal table, into this hash table with the help of index. Okay, you cannot insert the data also, right? So with the help of index you cannot do, with the key based operation you can do. Okay, so that's become little tricky. Okay, uh, so this is all about, and maybe tomorrow I will show you some example on this hash table, how you are going to do, and after that we will uh, close this types of different internal table chapter. Okay, and then we will move ahead. Okay, we will also see tomorrow, we will list out all the important differences. Some of the differences already I have noted it down over here, right here. So what we will do, that we will go into the PPT and we will list out all the important differences. Okay, and so that it will be easy for our difference. Okay, so with this, let's stop our today's session over here itself. If you have any doubt, please feel free to ask, please feel free to discuss. I will be happy to discuss. Okay, if you have any question, please feel free to discuss any question over here in this concept. This may be the new concept, I can understand, but this is the interesting concept. Okay, if you want to learn this concept in detail, you can go to the SAP standard documentation. Okay, you can go to the SAP help and there you can look out. Okay, but I would suggest you first practice whatever I have shared this knowledge over here, because it will be little difficult to understand directly from the SAP help documentation. SAP help internal table. So once you will get, once you will be having the good idea, about all this basic concept, then you can yourself go and you can learn from there. SAP help internal table. Okay, you can search and you can read out the documentation from here. Okay, so all the important thing, mostly a kind of summarized way I've tried to put you in front of you. Okay, any question, or shall we stop it over here? Others, you have completed the homework? Neha?
Sorry, sir. No, I am not completed because my server is the access of server is not working right now.